The world is standing on the edge of a computational revolution that will dwarf the impact of the Internet. While classical computers have reached their physical limits, a new titan is rising from the subatomic realm. Quantum computing is no longer a theoretical dream of physicists but a practical priority for global superpowers. Imagine a machine that doesn't just calculate faster, but calculates in a fundamentally different dimension of reality. This is the story of the race for quantum supremacy and why every nation is betting its future on a single qubit. Chapter 1. The Subatomic Logic. To understand quantum computing, we must first accept that the laws of our everyday world do not apply to the very small. A classical computer is like a library where you must read one book at a time to find an answer. A quantum computer is like a library where every book is open at the same time, allowing you to see the answer instantly. The fundamental unit of classical computing is the bit, which is strictly either a 0 or a 1. In the quantum world, we use the qubit, which can exist as both a 0 and a 1 simultaneously through a phenomenon called superposition. When you add entanglement to the mix, qubits become linked across space, sharing information instantaneously. This allows a quantum processor to explore a vast number of possibilities at once rather than checking them one by one. It is the difference between a candle and a light bulb. Both provide light, but the technology behind them is worlds apart. By tapping into the multiverse of calculations, these machines can solve problems that would take today's supercomputers 10,000 years. We are moving from the era of binary logic to the era of probabilistic reality. Chapter 2. The Cryptographic Doomsday. The primary reason every major country is pouring billions into this race is the threat to national security. Our entire global economy, from bank transfers to military codes, is protected by encryption based on hard math. Classical computers cannot crack these codes because they would take trillions of years to find the prime factors of a large number. However, a large-scale quantum computer could use Shor's algorithm to break almost all modern encryption in minutes. This is known as the quantum apocalypse, a day when all current digital secrets could suddenly become transparent. Nations are racing to build these machines not just to attack, but to develop post-quantum cryptography to protect themselves. Whoever reaches the finish line first will have the master key to the world's digital infrastructure. This has created a store now, decrypt later strategy, where adversaries are stealing encrypted data today, waiting for the day they have a quantum computer to read it. Information is the new gold, and quantum computing is the ultimate vault breaker. National sovereignty in the 21st century is now inseparable from quantum capability. Chapter 3. Material Science and the Medical Miracle. Beyond warfare and codes, quantum computing is the key to unlocking the secrets of nature itself. Classical computers struggle to simulate molecules because the math of chemical bonds is inherently quantum. This is why it takes over a decade and billions of dollars to bring a new drug to the market. A quantum computer can simulate the behavior of atoms with perfect accuracy, allowing us to design life-saving medicines in weeks. We are looking at the potential to cure Alzheimer's, design perfect vaccines, and personalize medicine for every individual. In material science, this means creating super materials that could revolutionize our physical world. Imagine a room temperature superconductor that allows electricity to travel thousands of miles without losing a single watt of power. Think of a new generation of batteries that can charge in seconds and power a car for 1,000 miles. Countries are joining the race because the first to master quantum chemistry will dominate the global pharmaceutical and energy markets. This isn't just about faster computers, it is about rewriting the periodic table to our advantage. Chapter 4. The Intelligence Multiplier. Artificial intelligence is currently limited by the massive amount of energy and time required to train large models. Quantum computing offers an efficiency leap that could make today's AI look like a pocket calculator. Quantum machine learning (QML) can process massive datasets with a fraction of the power and provide insights that are currently invisible. For a nation, this means having an AI that can predict economic shifts, weather patterns, and social trends with uncanny precision. In the 2026 landscape, the country with the best AI quantum integration will dictate the pace of global innovation. It will allow for the optimization of entire cities, managing traffic, energy, and logistics in real time without error. This intelligence multiplier is why the USA, China, and the EU are in a desperate sprint for talent and hardware. To lose the quantum race is to be left behind in the greatest cognitive evolution in history. The world's most complex problems, from climate change to global poverty, require a level of intelligence that only quantum systems can provide. AI gave us the brain. Quantum is giving that brain the power of a god. Chapter 5. The Global Geopolitical Tug of War. The race has created a new, quantum curtain, where technology is being shielded behind strict export controls. The United States and China are the two primary titans, each spending tens of billions on dedicated quantum research zones. China has already demonstrated quantum key distribution via satellite, creating an unhackable communication link across the globe. Meanwhile, the US leads in superconducting qubits, with companies like Google and IBM reaching milestones in quantum volume. The European Union has launched its quantum flagship to ensure it doesn't become a digital colony of the East or West. Even smaller nations like Singapore, India, and Israel are carving out niches in quantum software and sensing. This is a winner-takes-most game, where the first to achieve fault-tolerant quantum computing gains a permanent strategic edge. It is often compared to the space race or the Manhattan Project, but the stakes are even higher. The winner won't just land on a moon, they will land on the control panel of the global economy. In the 2026 era, quantum diplomacy has become the most important tool in an ambassador's kit. Chapter 6. The Engineering Everest. Building a quantum computer is perhaps the most difficult engineering feat ever attempted by humans. Qubits are incredibly fragile. The slightest vibration or temperature change can cause decoherence, destroying the calculation. Most quantum processors must be kept at temperatures colder than deep space, near absolute zero. We are currently in the NISQ era, noisy intermediate-scale quantum, where machines are powerful but prone to errors. The race now is to develop error correction, the ability to use many noisy qubits to create one perfect, logical qubit. This requires a massive supply chain of dilution refrigerators, specialized lasers, and rare earth materials. Every country is trying to secure its own supply chain to avoid being held hostage by global shortages. The infrastructure required to house these machines is turning into the cathedrals of the modern age. Scientists are experimenting with different platforms, from trapped ions and neutral atoms to photonic chips. We don't yet know which technology will win, so the world's powers are betting on every horse in the race. Conclusion. Quantum computing represents the final frontier of human logic, where we stop working against nature and start working with it. Every country is joining the race because they realize that the old rules of power are being deleted. Military strength, economic stability, and scientific progress now all flow through the same quantum pipe. While the challenges are immense, the rewards are nothing short of a new era of human civilization. We are moving from a world of what is possible to a world of what we want to make possible. The race is not just about who builds the first machine, but who defines the ethics and the safety of this power. As we look toward the end of the decade, the quantum ghost is becoming a physical reality in our labs and data centers. The street has finally met the screen, and the screen has finally met the atom. We are no longer just observers of the universe, we are now learning to program its very fabric. The quantum race has no finish line, only a new beginning for the human race.